Okay, so this next video lecture is still the continuation of our Module 6, Just-in-Time and Backflash Accounting. So to continue, we are now in the special consideration for Kanban scheduling for just-in-time. Okay, so Kanban, as mentioned earlier, this is a Japanese scheduling system that's often used in conjunction with lean manufacturing and GIT. So the father of GIT, Taichi Ono, he is an industrial engineer at Toyota. So he developed also Kanban in an effort to improve manufacturing efficiency. So this system highlights problem areas by measuring lead and cycle times across the production process. So this helps identify the upper limits of work or for work in process inventory in order to avoid overcapacity. So in this case, basically, Kanban is part of eliminating the waste. So lead time is from the time the supplies were ordered and until it was put into production and until the production is finished. Okay, so and at the same time, the time cycles across the production were analyzed. So here, basically, what this system wants is to avoid or to determine, okay, what problems will be encountered during the production. So of course, to eliminate the waste or possible wastes. Okay, so this is very important, especially in scheduling for just in time. So meaning they should incorporate those time lags, okay, in placing their orders of inventory to avoid stock out or even overstock of those raw materials or inventory. So how does our GIT differ from the traditional manufacturing? So here, in traditional manufacturing, we try to predict what the customer want. Okay, so meaning what the customer will want, and we will create a forecast based on that, or a guess. Okay, or of course that should be supported with reliable data. Okay, against which we will produce our products. That's under the traditional manufacturing system. So in that case, the entity will also try to produce those products in large batches as they believe that it will make the machine and processes more efficient, especially if those machines require a long time to set up. Okay, so to complement or to compensate for the longer setup time, so they will produce more. Okay, so this will typically result in long lead times in the production process. Therefore, huge amount of work in process stocks are also in large quantity, and also the finished goods stocks, okay, are of great quantity which have not yet been ordered by the customers. So this will because of this problem, okay, so most entities now actually are they are using just in time, okay, to eliminate this type of problem. So this traditional manufacturing system is what we call just in case manufacturing. Okay, so meaning they produce more, okay, to avoid stock out, okay, and also to compensate for longer setting up of the machineries, and also the cost of processing. Okay, just in case. If a customer does not order something, meaning that is not in our current stocks, they will either have to wait many weeks or even months for the products to be manufactured or worked. Okay, and it will be hurried through the system by progress chasers, causing a huge amount of disruption in their production schedule. So this is another problem with just in case. What if the customer order is not something that they produce? So they were and the order just came in and the entity would uh, produce them, okay, in a short period of time to meet the set schedule. Okay, so this is another problem of a traditional or just-in-case manufacturing. So these systems are often run by manufacturing resource planning, okay, or MRP programs that will try to schedule each and every process within the facility. So this is actually created to meet this problem. Okay, so there are software packages that will seek to control every step and everything, okay, carefully and in, uh, often include complex planning, okay, to eliminate those problems. So a just-in-time system, on the other hand, it seeks to use simple visual tools known as Kanbans. Okay, they pull the production through the process according to what the customer actually takes. And it massively reduces the amount of stock held and will reduce lead times by a significant amount, and often from weeks to just a few hours or days. So just that's how efficient just-in-time system is compared to our traditional manufacturing. So that's why, as mentioned earlier, most of the entities now are using this system. Okay, although it cannot be perfected in the first try, but they are continuing to improve and learn, okay, about how to make just-in-time system appropriate and useful and successful in their operations. So the benefits of GIT system. Okay, so of course it will reduce in the order to payment timeline, meaning the time lag, okay, between the order and the production until the inventory is finished and sold ultimately to the customers. Okay, so as in finance, we call cash as the king, okay, in business. So many business will suffer with cash flow problems as they will often have to purchase large amount of raw materials prior to manufacturing and subsequent payment by the customer. So this is the problem. They already spent their cash for purchasing the raw materials, but the inflow coming from the proceeds of the sale from the customer is it takes time or longer time. So there is a gap. So this gap may be in many months. Okay, so therefore the entity will suffer in their cash flow. So through implementing the just-in-time, in this case, the entity will be able to considerably reduce that time period, because what they will order as their supplies for raw materials will only be the items needed for production that is ordered by the customer. So therefore, the time lag between these two is shortened. Another benefit of our just-in-time system is it will reduce inventory cost. One of the main aims of GIT implementation, of course, is to improve stock turns and the amount of stock being held. Okay, personal experience has seen reductions of more than 90% stock in some industries. So that's how efficient just-in-time system is. So along with the reduction in the stock come many other associated benefits as well. Another benefit is reduction in space required because you only ordered what is needed. Okay, so by removing large amount of stock from the system and moving process closer together, this often see a significant reduction in the amount of floor space being used. Results from 100s of projects run within company in the UK through the manufacturing advisory service saw average reduction of 33% for simple 5-day implementation projects. So see, that's how effective and efficient just-in-time is. Another benefit is there is a reduction in handling of the equipment and other costs. So if you don't have to move large batches, there is less need for complex machinery to move them and all other associated labor and training as well. Another is lead time reductions. Okay, this is one of the most significantly impacted areas of the production flow process. So instead of weeks or months, most GIT implementations result in lead times of hours only or even a few days. So just imagine Another is reducing planning complexity. So the use of simple pull systems such as Kanban, even with your suppliers, can significantly reduce the need for any form of complex planning. With many implementations, the only planning is final shipping process actually once the order is placed. Another is there is improved quality. So the removal of large batch manufacturing and reduction of handling, this will result in significantly quality improvements. So often in the region, there are 25% or more improved quality recorded. Productivity will also increase. So to achieve GIT, there are many hurdles that must be overcome with regards to how the process will flow. This will often result in productivity later on. Okay? Up to 25% upwards, Another is problems are highlighted quicker and solved earlier. Okay, that is very important. Often this is cited as being a negative aspect of GIT and that any problems will often have an immediate impact on the whole production process. However, this is perfect way to ensure that problems are highlighted and solved immediately when they occur, and we do not wait for it to have a great impact over the procedure or the processes or the manufacturing or even in the entity as a whole. Employee empowerment. Okay, one requirement of GIT is, as with most other aspects of lean manufacturing, is that employees are heavily involved in the design and application of the system because they are the ones who are working hands-on. So that's why they are involved. Many definitions of just-in-time and lean itself will state that waste reduction is the aim here. Waste reduction, however, is actually something that we achieve through trying to implement the flow of other improvements required to achieve just-in-time and not the end of itself. Okay, so basically, aside from eliminating the waste, we see there that there are a lot of other benefits that we can gain from using just-in-time system in our manufacturing system. So, after determining the benefits of just-in-time, what are the requirements for implementing just-in-time? Okay, of course, just-in-time will be able to work if there are reliable equipment and machineries that is being used. Okay, it will also follow. If your machinery is always breaking down or giving you quality problems, then it will frequently manifest in big issues with GIT flow. So it will not complement what we want to achieve. Okay. So the implementation of total productive maintenance is required. This is to ensure that we can rely on the equipment to minimize the impact that any failures have on the process. Okay. Well-designed work cells. In this case, if the entity has poor layout, there is unclear flow of the process, and a host of other issues, this can all be cleared up by implementing 5S within the production. So this is part of the continuous improvement. I forgot the 5S actually, but I think this includes sorting of the items so that you can easily take what is needed, eliminating those items which are not needed. Another is the entity should make sure that there is clean environment. Okay, so we will just look into the 5S. I forgot the exact terms. Okay, but I am familiar with this because in quality control, 5S is an essential. Okay, so, 5S, sorting, setting in order, shine, meaning cleanliness, standardizing, and sustaining all of these practices. That's 5S. Okay, so this simple and very easy to implement lean tool will make a significant improvement in the efficiencies all by itself. Another is quality improvement, of course, as mentioned. So An improved or empowered workforce that is tasked with, with tackling their own quality problems with all of the support that they need is another vital part of any Lean and GIT implementation. So we set up Kaizen or quality improvement teams and use quality tools to identify and solve problems. This is very important. A part of the quality improvement. Another is there should be a standardized operation. Okay, only if you know how each operation is going to be performed can you be sure what the reliable outcome will be. Of course, defining standard ways of working for all operations will help the entity to ensure that their process are reliable and predictable. Meaning, standardizing is using the same simple process for the same nature of item in the production process. Okay, so we don't use different types of processes. For each item. If we can consolidate them, then we can simplify the process or the production. Another thing for the GIT, okay, to be successful in implementing is pull production, meaning just in time does not push raw materials in at the front end to create inventory or push the production. It seeks to pull production through the process. Okay, as mentioned earlier from the concept of just in time, okay, the entity will produce according to the customer's demand. So that's pull production. It achieves this by setting up supermarket concept, okay, where just in time started, okay, between different process from which products are taken or use Kanbans, which signals the red flags to tell previous process what needs to be made. Okay, so this is very important consideration in setting up and implementing your just-in-time system. Another is single piece flow or simplifying the process. So the ideal situation is one in which you will produce a single product as ordered by by the customer. This, for some industries, is not immediately possible, but they should always be their end goal. Okay, to achieve this, they will need to work on reducing batch sizes significantly through the use of single-minute exchange of dye or cement, which seeks to signify or significantly reduce the time taken for any setup. So here, it will also often require the use of smaller dedicated machines and processes rather than all singing, all dancing mega machines. So that's why in GIT, they are using this workstation or cell. Okay, this will be the system of flow that they will use in the production. So workstation or cell is a step, okay, in the production. So meaning whatever the item that will be produced, if they have the same production process, so they will have to go through that station at the same time to avoid and to lessen the lead time in the production. Okay, and lastly, flow at the beat of the customer. Of course, the demand of your customer is often referred to as your talk time. You need to ensure that your cells and processes are organized, balanced, and planned to achieve the pull of the customer. So this is achieved through Hijunker and Yamasumi charts, but I did not include it in here. So these are the tools that they can use or the entity can use in simplifying, okay, their process flow to meet the customer's demand. Okay, and also to ensure that the cells and process are organized and balanced. So again, these are Japanese charts. Okay, so those are the important considerations that is needed so that the implementation of just-in-time system in an entity will become a success. Okay, so what are the example of just-in-time? Okay, so famous for its GIT inventory system, of course, Toyota Motor Corporation, where GIT system come from and was born. So here they order parts only when it receives new car orders. Although the company installed this method in the 1970s, it took 20 years to perfect it. Sadly, Toyota's GIP inventory system nearly caused the company to come to a screeching halt in February 1997 after a fire at Japanese-owned automotive parts supplier Aisin disseminated its capacity to produce their PE valves for Toyota's vehicles. So this is a problem. So they should at least have more than supplier. Okay. Because Aisin is the sole supplier of this part, so its weeks-long shutdown caused Toyota to halt production. Okay, and it's caused delays. So this caused a ripple effect where other Toyota parts suppliers likewise had to temporarily shut down because the automaker had no need for their parts during that time of the period. So consequently, the fire cost Toyota 160 billion yen in revenue. Okay, so that's a setback. That is just one setback of just-in-time. But to avoid this, they should have at least more than one supplier. Okay, so the terms short cycle manufacturing used by Motorola. So this is, and a continuous flow manufacturing caused by IBM are synonymous also with GIP system. Okay, so how do we account for just-in-time manufacturing transactions? So here, accounting for GIP is done considering the purchase of raw materials directly for production. Okay, so meaning, in this case, once they produce or they purchase it, it will immediately be placed in production. And the lack of sufficient time to completely charge to production are all the elements of cost. So consequently, purchases of raw materials are charged to raw and in-process account. Okay, we do not separate the raw materials with the work in process account because under GIP, again, we order only once there is we order the inventory only when there is the order from the customer. So basically, what they order is placed to production. Okay, so that's why we will use raw and in process account title, and then this will be transferred to cost of goods sold. Okay, so conversion cost, which is the direct labor and factory overhead, may be accumulated first in the conversion cost account, okay, before they are transferred to cost of goods sold. And in some cases, raw materials remain in the raw and in process account until the latter is adjusted for the amount to be transferred to finished goods and cost of goods sold. To understand better, so we have here the illustration of how entries are made for just-in-time. So in this illustration, we have the traditional versus just-in-time. Okay. For purchasing of raw materials in traditional accounting, our entry is to debit raw materials and credit to accounts payable. But if we are using just-in-time system, our entry is to debit raw and work in process account debit and the same credit for accounts payable. If there is requisition of raw materials, for traditional accounting, we use work in process as the debit and we credit raw materials account. But under the just-in-time, there is no entry because this amount was already debited from the time that the raw materials were purchased. Okay? Another, for labor cost incurred. For traditional accounting, our entry is to debit work in process, credit to payroll or salaries payable. But in just-in-time, what we use in the debit is conversion cost account, which is the accumulation of the labor and factory overhead costs. Next, entry, factory overhead incurred. So for traditional, our entry is to debit factory overhead control, credit to sundry account, meaning it may be indirect materials or indirect labor. Okay. For just-in-time, again, we will use conversion cost. Factory overhead charged to production. So for traditional, we use work in process, debit, and then we close the factory overhead control. But under the just in time, there is no entry anymore because conversion cost accumulates the labor and factory overhead, and later on will be charged to cost of goods sold or finished goods. Okay. What about if the production is already complete? Okay, so for traditional accounting, we debit finished goods for the total and we credit the work in process. Okay. For just in time, we debit also finished goods. Okay. Raw in process and credit to cost of goods sold already, okay, upon the completion. Because in just in time, what we produce is actually ordered. This is a sure sure sale, I mean, of the inventory. So that's why we directly credited it to the cost of goods sold. Okay. At this time, we credit it temporarily at cost of goods sold. Okay, so in this case, so finished goods is 20% of completed goods. Okay, that's why if you could notice, your finished goods is 655. Our raw and work in process is 1,425. Okay, actually, okay, 60%, 20% of that. Okay, so in this case, our finished goods, okay, this is from 3,275. Okay. Later on, we will have, to understand better, I think, of these entries, we will have the illustration under the backflash entry. Okay. So we have there the table, okay, to show where this finished goods item was from. Okay, I think it's here. We will just show. Okay, this is the table. Okay, so cost of goods sold per entry. Okay, so the completed goods right here is item B. So this is 3,275. Okay, this is from raw materials of 2,000, direct labor of 600, and factory overhead of 675. Our raw and work in process right here is 1,425. So this is for 1,000 materials, 200 of direct labor, and factory overhead of 225. Okay, so finished goods here is 655. So this accounts for 20% of the completed item. Okay, so for 100 of materials, this is 20% of 2,000. Okay, 120, 20% of 600, and 135, 20% of 675. So these are our entry, okay, in the just in time. So we debit raw and work in process 1,425, finished goods of 655, and credit to cost of goods sold of 3,275. So we'll just go back right here. Oh, this is 280. I think, wait. Okay, 655 plus 1,425. Okay, that's 2,080. I mean, sorry. Okay, so we just add these items. Okay, so cost of goods sold credit is equal to 2,080. So this is for the entry under the just in time. Okay, at the completion of, okay, the goods. Okay. Next, for total production cost taken up as completed and therefore charged to cost of goods sold, 80% of finished goods. So in this case, our traditional accounting entry is to debit for cost of goods sold 2,620. Okay, so this is 80% of our finished goods of 275. Okay, so going back with this table, our completed units for cost of goods sold is 3,275. So 80% of this is 2,620. So debit cost of goods sold 2,620, credit to finished goods 2,620. Whereas for the just in time journal entries, so our entry will be to debit cost of goods sold, okay, 4,700. So 4,700 from this table is, okay, I think this is the total, okay, of all the items. So 3,275. Okay, so completed and raw in process. 3,275 plus raw and work in process of 1,425. Okay, so in this case, this is like raw and work in process of 3,000 and conversion cost, okay, of 1,700. Okay, so in this case, this is the total production cost, okay, which were already completed. Okay, if we will look into this table, in our just in time, okay, we refer to this column right here, letter A. Okay, so 47 is our debit for cost of goods sold. And then for our raw and work in process, that's 3,000. Okay, and then for our conversion cost, so this is direct labor and factory overhead of 800 and 900 respectively. So that's 1,700. So this is where our entry came from, okay, under the just-in-time accounting. Okay, so those are the difference between our traditional and just-in-time journal entries.